let's discuss how to graph g, which is negative log base 5 of x, using transformations. And we'll also state the domain and range of g and the vertical asymptote. Okay, so let's start with a basic logarithmic function. So a basic logarithmic function, and then we'll graph that basic logarithmic function. We'll do transformations to get to what g is, the graph of g. So f, the basic logarithmic function, we'll define to be f, and this will be log base 5 of x. Okay, so why is it log base 5 of x? Well, the basic logarithmic function will have the same base as the function you're trying to graph. So the same base as g. F will have the same base as g. And then it'll always be of just x. Okay, so there'll always just be x here. Even if g was x minus 1, this will still be x here. Alright? So this is the function f. This is the function we'll graph first, and then we'll use transformations to get to the graph of g. So actually, let's see, what will those transformations be? Let's think of what's g with regards to f. Well, it looks like g and f are the same thing, except there's a negative f of x. G is negative f of x. Okay, so what's this transformation? Well, this transformation is whatever y used to be, whatever the value of y used to be, it's now the negative version of that y. So that's a flip over the x-axis, right? Because whatever y, if y used to be positive, now it's going to be negative, so that's a flip over the x-axis, right? Okay, so let's go ahead and start thinking about this graph of f, and then we'll use transformations to get the graph of g. So let's go ahead and start trying to draw this graph of f. Okay, so this is just going to be a sketch, but so there's a few points that we should always try to graph for log functions. So let me go ahead and put those over here. Okay, so this is f of x, or y, right? Y for f of x. Okay, so a few points you should always try to graph are y equals 1, 0, and negative 1. Okay, these are just 3 easy points to figure out what x equals. So the let's think about this function here, log base 5 of x. Okay, let me use a different color for this. So this is the same thing as let's say y equals log base 5 of x. Okay, so logs equal exponents. That's the same thing as saying 5, the base is 5. So 5 to the exponent y equals x. So 5 to the exponent y equals x. Okay, so when y is 1, x is going to be 5. When y is 0, x will be 1, right? Anything to the 0 power is 1. When y is negative 1, x will be 1/5. Okay, let's go ahead and plot these points on our graph over here. So I'm going to go ahead and mark several points. 1, 2, 3, 4, 5. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. So when y is 1, f is 5. When y is 0, f is 1. I mean x is 1. And when y is negative 1, x is 1/5. Okay, so that'll be down here. Now, all of these basic logarithmic functions have an asymptote here, right? They have an asymptote on the y-axis, or the y-axis. And why is that? That's because, here, let me draw that asymptote actually in a different color so we can see it. So this is the asymptote on the y-axis. Well, why is that? It has to do with, there's no value of y where I'm going to get a negative value of x. There's no value I can plug in here for this y and get a negative value of x. X is always going to be positive, right? Even if you plug in really negative values of y, I mean, that just makes it, you know, so like if y is -2, that's 1 over 25, right? If y is -3, that's 1 over 5 to the third power, right? So 1 over 125. And so it gets really close to 1, or sorry, really close to 0, right? Really small number, but it will never cross the y-axis. All right, so here's the graph of f then. Okay, so it's going to approach that asymptote down here. And then it's going to continue going up high, right? Because when y is 2, it'll be all the way over here, 25, right? So it's going to continue going up in this direction gradually. All right, great. So there's the graph of f. Now I just have to do some transformations on those 3 points that I just plotted to find the graph of g. So I'm going to be flipping over the x-axis. That's all I need to do. That's my only transformation. So this point used to be y was +1. Now it's going to be y is -1. Same value 5 for x. Okay. This point doesn't change because y is 0. Y is going to continue being 0. Now that point is y is -1. X is 1/5. So that's going to change to being +1, and x is still 1/5. Alright, so still going to be approaching that asymptote as I go up now instead of going down. I'm going to gradually go this way. Alright, there you go. That's my graph of g. Okay, so now the next part in this question is to state the domain and range of the function and the vertical asymptotes. Okay, so it's domain and range of g. Right? So domain, let's start with domain. So domain, what x is allowed to be. Well, it looks like there's a vertical asymptote that's kind of stopping x from being any negative number. So it's gonna start at 0, not include 0, right? There's no value y I can never actually get x to be 0. So start at 0, go on to infinity, right? Go on to infinity in this direction. What about the range? Okay, so I'm going to go very high, that's obvious. But then also this actually goes can go forever low down to -infinity. It's going to do it really gradually, but it can be any number, right? So y, you know, the power can be any number as low as it wants to be, right? So the range is -infinity to infinity. Alright, lastly, the vertical asymptote. Well, we see it there. It didn't get transformed, so it's the same as the basic logarithmic functions vertical asymptote. So that would be x equals 0, right? Where x equals 0, you have an asymptote.